What happened to your good evening, all of you, Nana. Okay. So, yesterday what we have discussed, uh, Rutherford's theory, right? And somebody asked me repeat today. Okay.
Yes, sir.
Just I'm repeating it. See, don't write anything. Okay. This I'm going to erase also up again, because as you have asked me yesterday to repeat this concept again, that's the reason I'm repeating. Okay. Generally, what is there? No. So this is gold foil we are going to use. Okay. And when alpha particles are, this is some source of alpha particles, and alpha particles are moving like this. Okay. To observe these alpha particles are moving and bouncing back, so it was completely surrounded by what we can say, some fluorescent screen, some zinc sulfur screen is there. So when he observed that when these are the alpha particles means helium 24. When these helium 24 particles are passing, no, so he have observed that most of the alpha particles are passes through the foil. Okay, most of the alpha particles are passes through the foil, right? And in that one, and very few particles are bounced back like this, and very few, let us 1 mm 1000, so are bounced back with 180 degrees of angle. So these are the three major observations made in this experiment. Okay. So what? Most of the alpha particles are passes through, and very few are bounced back, and very few are reflected deflected with small angles. Now see here. In this one, what we can say, these are helium 24 means what? Which are positively charged molecules. That means it having positive charge. Now he is saying that from this one. So if I'm taking this is the atom. Okay, let me assume like this. He was not assuming it was atom is in spherical shape. Just I'm assuming. So into that one, he said there is a positive charge will be there, which is concentrated on the small region. This is positive charge, which we are saying that nucleus, and remaining part is empty. Okay. So as we know, from when we are having any empty region, so obviously alpha particles or anything also can be thrown away from the empty space. That's the reason what we can say, as from this, as alpha particles are, most of the alpha particles are passes through, he said most of the space in atom is empty, and this is what positive charge. And these alpha particles are positively charged. When these positively charged particles are hitting the nucleus, so they will come bounce back like this. Okay, that means what? That very few particles only bouncing back. That means the positive charge is completely concentrated in small region only, and this is the positive charge. If alpha particles are exactly hitting on the center, then they will bounce back with 180 degrees of angle. Whereas if the alpha particles are deflected, if it is hitting on the walls or at the corners, then it will deflected with small angles like this. Okay, so these are the points he observed. So from this one, he made certain points. That is what? In atom, most of the space is empty. Okay, most of the space is what? Empty. And into that one, positive charge is completely concentrated in one region only. So that positively charged area only, he is saying that nucleus. So around this nucleus, electrons will, this is nucleus, right? So this he is considering as a sun. Okay, or nucleus. So actually in atom nucleus and outside sun it is. And around the sun, how planets will revolve? Planets will revolve in this way, right? So he is considering, please, planets as a nuclear electrons. So that means simply around the nucleus, electrons will revolve in such a way that atom should get stable. Okay. That's the reason only simply is saying that electrons will revolve around the sun, how planets will revolve around the nucleus. That's why this model is called a planetary model, we can call. Okay, that's why this is called as a planetary model. So these are the points which we have discussed yesterday. Okay. Now there are certain drawbacks also there. Okay, drawbacks also there. What are the drawbacks? We will see that. Drawbacks is, for example, if this is the nucleus, right? Hello, what happened, Anna? Hello, anyone wants to say anything? Drawbacks are, so this is the nucleus, right? So he is saying that with a particular distance, only electrons are revolving. Okay, electrons are revolving like this. Okay, according to classical law of physics, if any particle is revolving with a particular distance r, then for example electron is there, here it is electron, this electron is revolving around the nucleus like this. If it is revolving, then what will happen? It will continuously lose its energy and it will fall down to the nucleus. Okay, it will fall down to the nucleus. If it is electron is falling into the nucleus, it should get collapse, right? But in actual practice it is not happening. That means why it is not happening, that point also not able to explain. That means what he is trying to do, let me write here. According to according to classical law of physics, if a particle is revolving around the nucleus with a with particular distance, with particular distance continuously, it should lose its energy. It should lose its energy and fall into the nucleus. Okay, nucleus. If it happens so, if it happens so, atoms should get collapse. But in actual practice, it is not happening. It is not happening. So why it is not happening? It was not explained. Okay, this is the first part. And one more point is, it doesn't explain the spectra of atom also. Okay, so these are the 2 points which was not explained. That means what are the points? If around the nucleus, if a particular atom or anything is revolving around the nucleus, it's supposed to lose its energy and it should fall into the nucleus, so which is not happening. So why it is not happening? What is the reason? It was also not explained. Mm. This is about the drawbacks. So next one we are going to discuss. Okay. Before going to do that, we need to know certain points. We need to know. Na? Students, 1 second. Mm. Okay, na, students. So this is next one. Here we need to know certain points before going to discuss Bohr's theory. That is atomic number.
Sir, what is meant by spectra of atoms, sir?
I will tell you, Nana. So we need to discuss spectrum also. Okay, just we need to give a little bit idea of spectrum also. In hydrogen spectra, hydrogen atom, I will explain what is spectra, how things will going to happen. Okay, na?
Okay, okay, sir.
So atomic number means it is number of protons are number of electrons of a neutral atom. Okay, this is atomic number. And atomic number generally we will represent with okay, it is denoted or represented by Z. Okay, and uh, atomic mass. Generally, atomic mass is the summation of protons. It is the summation of protons and atomic mass is the summation of protons and neutrons. Atomic mass is the summation of protons and neutrons, we can say. Okay. Generally, it is denoted by E. Okay. Next one, number of neutrons. Number of neutrons. So number of neutrons equal to, that is n equal to mass number minus atomic number. A means what? Mass number minus atomic number. For example, let me take it as an X, an element is there. Okay, arbitrary I'm taking as an X as an element I'm going to take. X, this is atomic number Z, and here we can write as A. So in this one, what X indicates? X indicates element, and A represents mass number, and Z represents atomic number. Okay. Okay, చూడండి. నా ఒక క్వశ్చన్ చూద్దాం. Calculate the number of protons, neutrons, electrons of the following. Example, bromine 3580, 710, 37, Na plus 11, 23. So in that one, let me see. In case of bromine 80 and 35. In this one, what is number of protons? Number of protons is nothing but atomic number, right? That will be 35. And this is neutral molecule, so number of protons and number of electrons will be same. And the number of neutrons equal to what? Number of neutrons is equal to mass number minus atomic number, that is 45. Okay. Next one, in case of chlorine 17, 37 minus, if I'm taking. In this one, number of protons, same. Protons will remain same only, 17. Whereas number of electrons will be how much?
17.
What you're asking, Anna? Somebody is asking something.
No, sir.
Number of electrons, how many it is there? Minus means what? It is gaining one electron, right? Okay, number of okay, Anna?
Yes, sir. Yes, sir.
Number of electrons equal to how much it will be there? That will be 17 minus 1, no? That is 18 electrons. Okay, because minus 1 means what? Gain of electrons. And the number of neutrons equal to how much? Mass number 37 minus 17, that will be 20. So positive charge aithe we need to subtract the electrons, and negative charge means okay. Next one, Na plus 11, 23. What is number of protons? Number of protons how much, Rama?
11, sir.
Number of
11, sir.
protons 11. Very good. Number of
11,
electrons?
sir.
Number of
10, sir.
electrons?
10.
11.
10.
Number of
Sir.
electrons are 10.
10.
Because 11 minus
Plus
1,
1.
no? And number of neutrons equal to
Neutrons are 12.
12.
12.
Very good. Okay.
12.
Okay. 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 So this is what we can say about the uh, calculate how to calculate number of protons, neutrons, and electrons. Okay. Next one we are going to discuss about the Bohr's theory. Okay. Mm. So Bohr's theory. So as you know, it is proposed by Bohr, Niels Bohr. Niels Bohr. Okay. Next one, what we can say? This theory is based on. Acha, you don't know Planck quantum theory, right? Okay. We will discuss that also. That also we need, no? Planck quantum theory.
Sir, Planck quantum theory remaining and Westphal theory.
Which one, Anna?
Westphal valence electron shell pair repulsion theory.
That is a chemical bonding topic లో ఉండదమ్మా. వాలెన్సీ ఎలక్ట్రాన్ పేర్ రెస్పాన్స్ థియరీ అనేది కెమికల్ బాండింగ్ లో. ప్లాంక్ క్వాంటమ్ థియరీ అనేది మనం స్ట్రక్చర్
Okay,
ఆఫ్
sir.
ఆటమ్ లో డిస్కస్ చేస్తాం. ఓకేనా?
Okay, sir.
So Planck quantum theory, what she says that, so the energy, I think you people know this, I think the energy emitting from
Size,
any source, ఏంటమ్మా?
nothing, sir. అంటే సిగ్నల్ తక్కువ ఉంది.
Energy, energy emitting from any source comes discontinuously in the form of small packets called quanta. అంటే this is source if I'm taking, no, so it will come like this. This is one quanta, this is one quanta, this is one quanta, this is one quanta, like this we are going to. These are what small energy packets. Simply we can say. Okay, small energy packets, which is also called as a quanta. In case of light, these quanta are called photon. This quanta only called, what we can say, it is a photon, we can say. Okay, na? Photon we can say. And next, the energy of the photon, is directly proportional to frequency. That is, energy E is directly proportional to frequency nu. And by removing the proportional symbol, we will use E equal to h nu. Here h is called Planck constant. Planck. And that value is, h value is 6.625 into 10 to the power of minus 34 joules second, and H value 6.625 into 10 to the power of minus 27 arc second. Okay, this is what we can say about the uh, Planck quantum theory. Okay. And one more point you need to remember, that is one more relation, C equal to nu lambda also you need to remember. Here C is what? C is known as velocity of light. That value will be 3 into 10 to the power of 8
per meter per second.
meter per second, or 3 into 10 to the power of 10 centimeters per second. Next here nu is frequency,
And lambda is
lambda equal
wavelength.
wavelength. Very good. So from let me take, this is equation number 1. Let me take this is from this one what we can write, nu can be written as C by lambda. From equation 1 and 2 what we can write, 1 and 2 we can write E equal to H into, instead of nu we can write C by lambda, which means E equal to Hc into 1 by lambda. 1 by lambda means nu bar. That is 1 by lambda is known as a nu bar. Here nu bar is known as what? Nu bar is what? An wave number, right? This is what we can say about the, okay, this is known about the what we can say wave number and this formula, Planck quantum theory. Okay, na? So these formulas you need to remember. Na? E equal to H by lambda and E equal to H nu. ఈ ఫార్ములాస్ ని గుర్తుపెట్టుకోవాలి. ఓకే, నెక్స్ట్ వన్ ఈజ్
సార్
చెప్పనా,
దీని రికార్డింగ్స్ తర్వాత గ్రూప్ పెడతారు కదా సార్?
నేను అర్థం కాలే.
రికార్డింగ్స్.
రికార్డింగ్ సార్ పెడతారా, మీ గ్రూప్ లో పెడతారు కదా.
ఓకే సార్.
ఓకే, నెక్స్ట్ వచ్చేసరికి బోర్స్ థియరీ. Bohr's theory, as I suppose it is proposed by Niels Bohr, right? This theory is based on Planck quantum theory or Planck's theory. Okay, next according to this, what he is saying that no. So as Rutherford said nucleus, no, he is also accepting that atom, in atom there is a nucleus will be there. Okay, now in this one what we are saying, that one see here. So around the nucleus, there are infinite number of around the nucleus there are infinite number of circular paths are available. Okay, this is the nucleus if I'm taking, no? See, Rutherford, he was not said which path. That means how electrons are revolving. Whether it is revolving in a circular path or elliptical path or any other direction, it was not explained. But he said clear cut. He is saying that electrons will revolve around the nucleus. There are infinite number of circular paths are there like this. Okay, infinite number of circular paths are there like this. Okay, up to we can have up to infinite. Okay, out of which out of which electron will revolve in those cells whose energy is okay. That means what? So for any atom also there will be infinite number of circular paths are there. Out of that, electron can revolve 1, 2, 3 in any direction it can revolve. Okay, whereas it will choose. So the electrons will revolve in a particular cells whose energy is constant. అంటే ఎలక్ట్రాన్ ఏ సెల్లో రివాల్వ్ అయితే దాని ఎనర్జీ కాన్స్టెంట్ అవుతుందో అదే సెల్స్ లో ఎలక్ట్రాన్ అనేది రివాల్వ్ అవుతూ ఉంటుంది. ఓకే, అదే సెల్స్ లో ఎలక్ట్రాన్ అనేది రివాల్వ్ అవుతుంది. అండ్ దీస్ సెల్స్ ఓన్లీ కాల్డ్ యాజ్ దీస్ సెల్స్ ఆర్ కాల్డ్ స్టేషనరీ ఎనర్జీ లెవెల్స్. Stationary energy levels. Okay, stationary energy levels under represented by K L M N O or K L M N O, so on, or it can represented with 1, 2, 3, so on. అంటే ఫస్ట్ సెల్ ని K के साथ, second cell is represented by L, third cell is represented by M, fourth is N, or 1, 2, 3, 4 like that represented. Okay, these stationary energy levels are these also called as orbits also we can say. These cells also called orbits. These cells also called what we can say orbits we can say, right? This is about the Bohr's theory point. Okay, next point. Whenever electron revolves in the same cell, electron neither lose energy nor gain energy. Neither lose electron energy nor gain energy. This is what we can say about the whenever electron revolves in the same cell, this is only going to happen. But if electron jumps from lower level to So he calculated which is having lower level, which is having higher level. In his theory, he calculated the energy values he had calculated. Okay. If electron jumps from lower level to higher level, then absorption of energy takes place. Okay, absorption of energy takes place. If electron jumps from higher level to lower level, if electron jumps from higher level to lower level, then emission of energy takes place. Energy energy takes place. Okay, na? This is what we can say electron whenever it is taking. Next one, the absorbed or emitted energy is equal to difference in energy levels, difference in energy levels, which is equal to h nu. For example, E2 is the higher energy level, let me consider, and E1 is the lower level, that is E2 minus E1 equal to h nu. Okay, that means if electron jumps from any energy level to any level, okay, if electron jumps from any energy level to any energy level, okay, then it will jumps from lower level to higher level or higher level to lower level, it will takes place. Okay, so that value will be equal to h nu naught. Now see, that is delta E equal to h nu we can write. And one more point we can write, that is what we can say, the angular momentum, the angular momentum of electron in an orbital is quantized, that is angular momentum we can relate mvr equal to nh by 2 pi. Okay, where n equal to 1 2 3 like that. So quantized means what we can say, that means for the first cell, angular momentum mvr equal to what we can write, h by 2 pi. For second cell, mvr equal to 2h by 2 pi. And the third cell,
3h by 2 pi.
yes, very good. So likewise For different cells, different values are there, no? This only we are saying that quantization we can say. Okay, quantization we can say. So this quantization,
Sir,
why it
that
will
means
take place?
sir, first cell means K, second means L. In that format only, no, sir?
Yes. Okay. Uh, so why that angular momentum is quantized? It was not explained. We will discuss how this will come. So this is about the Bohr's theory. So అర్థమైందా అందరికీ? Have you understood, students?
Yes, sir.
Yes, sir.
మళ్ళీ ఒకసారి
Yes,
చెప్తాను
sir.
చూడండి. మళ్ళీ ఒకసారి రివైజ్ సమ్అప్ చేస్తాను చూడండి. ఓకే, సో అరౌండ్ ది న్యూక్లియస్, ఈ థియరీ అనేది మనకి బోర్స్ థియరీ ఇస్ డిపెండ్స్ ఆన్ ది ఏ థియరీని బేస్ చేసుకున్నా, దిస్ ఈస్ బేస్డ్ ఆన్ ది ప్లాంక్ క్వాంటమ్ థియరీ. ఓకేనా, అంటే ప్లాంక్ క్వాంటమ్ థియరీని యూజ్ చేస్తాడు ఎక్కడ ఒక దగ్గర. అండ్ ఈ థియరీ ఏముంటుంది మనకి, అరౌండ్ ది న్యూక్లియస్ ఇన్ఫైనైట్ నెంబర్ ఆఫ్ సర్క్యులర్ పాత్స్ అనే ఉంటాయి. ఈ సర్క్యులర్ పాత్స్లో ఎలక్ట్రాన్స్ విల్ రివాల్వ్ ఓన్లీ ఇన్ దోస్ సెల్స్ హూజ్ ఎనర్జీ ఇస్ కాన్స్టెంట్. అంటే ఏ సెల్స్లో అయితే ఎలక్ట్రాన్స్ రివాల్వ్ అయితే ఎనర్జీ కాన్స్టెంట్ అవుతుందో అవే సెల్స్లో మాత్రమే ఎలక్ట్రాన్స్ అనేవి రివాల్వ్ అవుతాయి, కాన్స్టెంట్గా ఉండుద్ది ఎనర్జీ. ఓకేనా, ఇప్పుడు ఎలక్ట్రాన్ అనేది ఇన్ ది సేమ్ సెల్లో రివాల్వ్ అవుతూ ఉంటే దెర్ ఈజ్ నో లాస్ ఆర్ గెయిన్ ఇన్ ఎనర్జీ. బట్ ఎలక్ట్రాన్ అనేది జంప్స్ ఫ్రమ్ లోవర్ లెవెల్ టు హయ్యర్ లెవెల్ కానీ హయ్యర్ లెవెల్ టు లోవర్ లెవెల్ కానీ అయితే ఎలక్ట్రాన్ అనేది ఎనర్జీ లూజ్ అవుద్ది లేదా గెయిన్ అవుద్ది అనమాట. సో అదే లోవర్ లెవెల్ టు హయ్యర్ లెవెల్కి వెళ్ళింది అనుకోండి, ఎనర్జీ అనేది అబ్జర్వ్ అవుతుంది. అదే హయ్యర్ లెవెల్ టు లోవర్ అయితే ఎనర్జీ అనేది ఎమిట్ అవుతుంది. ఈ అబ్జర్వ్డ్ ఆర్ ఎమిటెడ్ ఎనర్జీ అనేది విచ్ విల్ బి ఈక్వల్ టు హెచ్ న్యూకి ఈక్వల్గా ఉంటుంది అనమాట. అండ్ వన్ మోర్ పాయింట్ ఏం చెప్పాడు, ది యాంగులర్ మొమెంటమ్ ఆఫ్ ఎన్ ఎలక్ట్రాన్ ఈస్ క్వాంటైజ్, దట్ ఈస్ ఎంవిఆర్ ఈక్వల్ టు NH/2π అని చెప్పాడు అనమాట. ఓకే, అండ్ ఈ స్టేషనరీ సెల్స్నే ఏ సెల్స్లో అయితే ఎలక్ట్రాన్స్ రివాల్వ్ అవుతాయో వాటిని మనం ఎలా రిప్రజెంట్ చేస్తాం, KLMN అలా రిప్రజెంట్ చేస్తూ ఉంటాం అనమాట. ఓకేనా, దీనే మనం ఆర్బిట్స్ అని కూడా మనం చెప్పుకోవచ్చు. సో దిస్ ఈజ్ అబౌట్ ది బోర్స్ థియరీ అండ్ ఇట్స్ పాయింట్స్. ఓకే, దీని తర్వాత బై యూజింగ్ బోర్స్ థియరీ హౌ ఎనర్జీ, వెలాసిటీ, రేడియస్ అనేవి క్యాలిక్యులేట్ చేయొచ్చు అనేది కొద్దిగా డిస్కస్ చేసి, ఓకేనా, వీ కెన్ గో ఫర్ అదర్ టాపిక్. రైట్ నానా? సో గుడ్ నైట్ all of you. Right, we will meet you in next classes. Right, bye all of you. Thank you.